We hear it all the time, right? AI is going to revolutionize education, make learning easier and faster than ever. But what if that feeling of ease, what if it's actually a trap? We're about to dive into this really fascinating study that uncovered a huge paradox. The AI tool that students absolutely loved the most was the one they learned the least from.
It really gets down to this question, doesn't it? Can an AI tool be so smooth, so helpful, that it actually fools you into thinking you're learning when you're not? Well, we're about to see just how disconnected our perception of learning can be from reality.
And this is the core mystery right here. A recent study put 3 different learning tools to the test, and the result? The AI tool that students said was the most engaging, the easiest to use, actually led to the worst test scores. So, what in the world happened?
To get to the bottom of this, researchers set up a randomized controlled trial with 124 people. The mission was simple: learn about meiosis from a biology textbook. But each group got a different AI assistant to help them out. So let's meet our 3 suspects in this little mystery.
First up, we've got MuDoc. Think of this as a super smart chatbot. You ask it a question, and it doesn't just give you a wall of text. It pulls the relevant sentences and the diagrams straight from the textbook. So it's a rich, visual, conversational experience.
Our second suspect is TexDoc. Now, TexDoc is basically MuDoc's identical twin. It's just as conversational, just as good at pulling answers from the text. But, and this is the key difference, there are no images. It's a purely text-based chat. That's it.
And finally, our third suspect is DocSearch. This is our baseline. You know, the old school approach. It's a classic search bar. You type in a question, and it just finds and highlights the relevant parts of the textbook. No conversation, no summarized answers. You have to do the reading yourself.
All right, so the stage is set. 3 tools, 1 biology topic. After everyone finished their learning session, they all took the same test to see what they actually remembered. So let's look at the evidence. This is where it gets interesting.
And wow, the results are pretty shocking. The group that used MuDoc, the AI with both text and images, they scored the highest. No big surprise there. But get this, the group using the text-only chatbot, TexDoc, they scored the lowest. I mean, even lower than the group that just used a basic search tool.
But here is the massive twist. When you ask the students which tool they liked the best, the story completely flips on its head. They found both of the conversational AIs, MuDoc and TexDoc, way more engaging and much easier to use than good old DocSearch. So they loved the text-only chatbot, even though it was the worst one for their learning.
And this brings us right back to that central puzzle. We've got an AI tool that feels fantastic to use, that students think is super helpful, but the data shows it's actually holding them back. So how is that even possible? Well, to understand this, we need to crack the cognitive code.
The answer to this whole paradox actually lies in a really powerful concept from educational psychology. It explains exactly how our brains learn, and, in this case, how they can get tricked into thinking they're learning. It's called cognitive load theory, and the basic idea is pretty simple. Your working memory, the part of your brain that's juggling information right now, it's kind of like a computer's RAM. It has a very limited capacity, and if you overload it with useless junk, there's just no room left for the good stuff. The actual learning. And there are 2 main types of this mental load to think about. First, there's extraneous load. That's the bad kind. Think of it as mental clutter. It's the effort you waste just trying to find information or figure out a clunky interface. Then you have germane load. That's the good stuff. That's the productive effort your brain uses to actually connect ideas and build real understanding. So the goal is always this: minimize the clutter to maximize the productive effort.
And this table, oh man, this table explains everything that happened. Look at DocSearch. It had high mental clutter, right? You had to work hard to find stuff. But all that reading also created high productive effort. So the learning was just okay. Now look at TexDoc. Its conversational style felt super easy, so it had low mental clutter. But, and this is the key, without any visuals, it didn't really push the brain to think deeply. So you had low productive effort and boom, poor learning. But MuDoc hit the sweet spot. It was easy to use, low clutter, but the mix of text and images forced the brain to do the productive work of connecting them. High productive effort, and that led to great learning.
This whole phenomenon actually has a name. It's called the Fluency effect. It's this sneaky cognitive bias where our brain mistakes how easy something feels to process for how well we've actually learned it. The students using TexDoc felt great because the answers were just handed to them so smoothly. But that very smoothness is what kept them from doing the deeper thinking they needed to do to really remember the material.
So, after looking at all the evidence, what's the verdict in the case of the AI learning paradox? Well, it's pretty clear. The goal for AI in education shouldn't just be about making learning feel easier. It has to be about making it smarter.
So here are the big takeaways. First, yes, conversational AI is great at cutting down on that mental clutter, which makes learning feel easier. But that feeling of ease is not enough. Without visuals to make you think, it can just create an illusion of learning. It turns out that integrating text and images is what really encourages that deep thinking that leads to real learning. So the best tools, they're going to be the ones that strike a perfect balance between being easy to use and making your brain do that productive work.
You know, the researchers themselves put it perfectly in their paper. They said, reduced cognitive effort may inflate perceived understanding without improving learning outcomes. I mean, that just nails it, right? It's a huge warning for all of us, whether we're students or the people designing these new tools.
And that leaves us with one last really interesting question to chew on. As we build this next generation of AI tutors and teachers, maybe the goal shouldn't be to remove all the friction, to make everything effortless. Perhaps the very best AI teachers will be the ones who know exactly how and when to make us think just a little bit harder, not less.